Hi everyone. Today we are talking about the disruptive innovation in laser technology and satellite network. 我是夏瑞阳. This is my presentation. Today we are talking about two parts. One is access network. The other is physical medium. For the access network, we are discussing about the satellite link. And for the physical medium, we are discussing about free space optical communication. So what is satellite link? It is a link, radio link, between two Earth stations via through one satellite. So what's the component of the satellite link? There are actually three main components in such access network. One is antenna, the other is satellite, for the final one is gateway. Let's talk about satellite first. Satellite usually have two types of communication. One is space-to-ground communication. The other is space-to-space communication. Let's talk about space-to-ground communication. Currently, space-to-ground communication are considered using narrow beam technology. This is because it can connect multiple antennas with the same bandwidth and adjust communication intensity individually, unlike the conventional system. What about the space-to-space communication? Currently, companies are considered using laser beam in the space communication. There are several reasons. One, it is very hard to build physical connection in the space. The second is the laser has high bandwidth than low-frequency radio wave. The second component in the satellite link is gateway. The function of gateway is to establish a connection between a satellite network to the internet backbone. The final component of the access network is antenna. Here we take a very small aperture terminal as an example, shown as the picture below. The antenna usually have three components. One is feed horn, second is block up converter, and the last one is low noise block down converter. For the feed horn, its function is to receive and send signal. And for the block converter, it is used to amplify the signal are prepared to send out. And for the low noise block down converter, its job is to filter out the noise and amplify the receiving signals. So what's the future of the satellite network industry looks like? In the past, one of the main challenges is the cost of sending things to orbits. In 2000, the cost to send 1 kilogram to the space is around $10,000. That is, in 2002, EchoStar launches an EchoStar 7 to the space, a 4,000 kilogram network satellite. It costs $40 million US. It's extent of the money. So company at that time trying to send as few satellites as possible with maximum coverage. That is, send satellites as high as possible. But it comes with great cost, huge latency. Latency is usually around 200 milliseconds for a round-trip latency from satellite to the ground. But the thing has changed. The price of sending 1 kilogram to the space has reached a historical low point. A rocket ship company called SpaceX is capable of sending 1 kilogram to the space with $2,700. Now, a new network satellite company called Starlink is currently executing a plan to deploy thousands of satellites into 550 kilometer orbits. Latency dropped to 4 milliseconds. Another change is happening. In the space, data can travel 1.5 faster than in the optic fiber. So what does it mean? Companies are trying to build a mesh optical network in the space. In theory, it can beat Hibernia Express cable, the fastest optic cable across Atlantic Ocean, with 17 milliseconds. This is a lucrative business. 70 milliseconds matters. In the past, companies willing to invest $300 million to construct the cable across Atlantic Ocean in order to gain 5 milliseconds faster. Also, Hibernia company charges users with $20 million for using Hibernia Express cable for 5 years. Now we are talking about the physical medium, free space optical communication. So what it is? It is optical communication technology that transfers data via light without a guided medium. This technology is extremely useful when constructing fiber cable is impractical or too expensive. Let's talk about a simple example. A signal lamp usually used to communication between ships, like the picture shown in below. Typically, the standard can encode data by either using FM or AM modulation. For a signal lamp, it is using kind of AM modulation. So what's the advantage and disadvantage of such technology? There are several advantages. Distance insensitive cost, high bit rates, low bit error, and immunity to electronic magnetic interference. But they also have some disadvantages. It can easily attenuate in fog, rain, or snow. Beam disperse in long distance, interference from background light source, and the connection can be unstable in the wind. What's the current development of the laser technology? Currently, the record laser transmission rate is at a level of Gbps in the space. From the picture shown below, we can see the transmission rate of laser communication multiply thousands for every 10 years. It is also possible to apply recent enhancement in optic fiber technology to laser communication, such as wavelength division multiplexing, space division multiplexing, and multi-level modulation. So what's the key takeaway from today's talk? So what is the future of the satellite network? One, as the bandwidth in the space can be as competitive as optic fiber, and the latency is much faster for long-range communication. Thank you for today's listening.